Okay, good afternoon, everyone. It's September 15th, and you're here for Economics 249. So we're going to finish up Chapter 3 today, and then immediately I'm going to start with Chapter 4. So before we do that, a reminder that your Excel assignment is due on Thursday, September 17th. This is a team group assignment. So I just need one person in your group to submit it online on Blackboard. And you won't get an immediate grade because I have to go through them. And your homework is due this Sunday. Okay. A reminder also that your first exam is next week on Tuesday, September 22nd. So pay attention to your syllabus, the schedule that's on your syllabus, and I can actually share that with you. So looking at the first page of the syllabus, you can see that exam 1 is going to cover chapters 1, 8, 2, 3, and 4. So 4, I'm going to begin today and finish it on Thursday. So if I look at the schedule on our syllabus, you can see that exam 1 is going to be on Tuesday, September 22nd. So I'll talk more about the exam later, but it will be on my lab, my stat lab, same place where you do the homeworks, the same amount of class time, so from 12:15 to 1:30. It's as if you're sitting in the classroom with an open book, right? Because you have access to all the previous homeworks, all the slides, the notes. So you can do all this on MyLab. You have a set amount of time. So you really have to study for the exam, because if you're going to waste time looking for the question, you won't have enough time to complete the exam. And I will send you a separate Zoom link because I need to have your camera on. And if you don't have a camera on your laptop, you can use your cell phone to access the camera. So you can. I need to be able to see your face when you're doing the exam. Also, I'm using Zoom for the exam rather than Blackboard Collaborate because you can change your background with Zoom if you don't want to share your background and keep your privacy. Okay, so questions in the chat. Paul asked me, is it multiple choice or like the homework? It's just like the homework. So the questions that you get in the homework, similar questions in the exam, very much similar. So that's the best way to study, right? Go over your homework questions, go over the extra problems that they offer you through the study plan. The scores that you get on the study plan are not scores that I use towards your course grade. I'm only interested in your homework score, but the study plan gives you extra problems to study. If you finish your homework and submit it on time, then you can always go back and view the questions and view the solutions as well. I am not sure at this point how many questions on the test. So I expect you to have access to all the material. So I guess it's an open book test, right? Yeah, anything else? So I will talk more about the test later on in the week on Thursday. But just remember that there's an exam next week on the 22nd.
Professor, I have a question about the Excel assignment.
Uh-huh.
That was given on Thursday, correct?
That was given on Tuesday.
Tuesday. The group work that we did?
So are you asking me about the Excel groups that I assigned or the assignment itself?
The assignment itself.
Yeah, it's posted on MyLab.
Okay, we didn't have class on the 10th, Professor?
10th? The
Yeah,
10th of...
September, because I wasn't here.
Okay, so if you want to send me an email separately, I'll answer that question. Okay?
All right.
Okay, so I'm going to share chapter 3, and this is what we did in the last class. We stopped over here. Okay, so this is what we did in the last chapter. We finished spread and we discussed standard deviation. Now, again, I expect you to use Excel when you're calculating standard deviation. If you're comfortable using your calculator with standard deviation, then that's fine too. But get used to the formula that you type into Excel, okay? So now what I'm going to do is discuss the 5-number summary and box plot and finish up with time series plot. Okay, so that is that brings me to this slide. Okay, so let's start with this slide today. So again, we're talking about how data is distributed. The 5-number summary of a distribution reports its median, quartiles, and extremes. So now you're looking at these 5 numbers, Q1, the median, Q3, the minimum value, and the maximum value. Now a little bit to backtrack, the median is also Q2. And what is this Q1, Q2, Q3? These are the quartiles. And I gave you the formula that we use for quartiles. I'll go back to that when we have to refer to it. Okay, so let me show you the next slide and then explain where this 5-number summary comes from. So the reason why we have a 5-number summary is because we can display it as this box plot. Some of you may have heard of a box plot before. Sometimes it's called a box and whisker plot because it has these things that kind of look like whiskers. So it's called a box and whisker plot. The center, the line in the middle is actually Q2. So let me write that on this. So that line in the center is Q2, or in other words, quartile 2, or it's also called the median. This point here at the end is Q1. So that's quartile 1. And this point here would be Q3. Quartile 3. And then there's 2 more things. Rather than calling it the max and min, we're going to call it the highest fence. So that point is the highest fence. And then this point here would be the lowest fence. The lowest fence. And then the points that you're seeing over here are considered the outliers. So those are the outliers. And again, the outliers are observations in your data set that are completely different from the rest of your observations. So these values now, the next few slides, I'm not going to read them. I'm actually going to show you how to construct a box plot, because part of your homework questions as well as your exam will ask you questions about a box plot. So you need to be able to do this manually, meaning taking a piece of paper and drawing it out. Okay, so let's start with that. I'm going to skip this. Again, skip this. Skipping this as well, and let's actually create a box plot. So here we are. Let's start with this. This is an example, and let's use these values. So the question says, Wayne Gretzky scored 50% more points than anyone else who played professional hockey. Here are the numbers of games Gretzky played during each of his 20 seasons. Create a box plot. Okay, so we're talking about Wayne Gretzky, and he scored 50% more points than anyone else who played professional hockey. So that information is not really necessary. Here are the number of games that Gretzky played during each of his 20 seasons. So you're given the number of games during each of his 20 seasons, and you're asked to create a box plot. So I'm going to move on to the next slide because it breaks it down into different steps. Okay, so using this data set, same data set that you're seeing on the top, step 1 says to create an ordered array. So I'm going to ask Arzu, can you rearrange the data for us into an ordered array? So you can type it into the chat box. I think that's the easiest. So I started the first two values for you. We start in increasing order, right? So 45, 48. And if you can do the rest for us. So also type in 45, 48. So while Arzu is doing that, the reason we're creating this box plot is because we want to have some kind of visual of the data and get a lot of information quickly, which we might not get with a regular histogram. Okay, so a box plot gives us more information. And then later on, I'll show you how a box plot can be compared with bunches of data, which means we're getting more information when we compare it with groups of data. Okay, did you rearrange it, Arzu? Can we see what you have? Okay, so we have 45, 48. I'm scrolling down. I think, are you missing some after 79? So we need 20, right? Oh, yeah, I see it. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I think that seems right. We have another 82, I think. Yeah. Okay, is that 20 observations? Can someone count for us, please? Okay, perfect. Okay, that's step 1. So when you get your data, rearrange it in increasing order. Step 2, calculate quartile 1, quartile 2, quartile 3, quartile 4. The formula is here, so you can follow this formula. And I'm going to have Abu, you're going to do quartile 1. Bitin, you're going to do quartile 2. Labna, you're going to do quartile 3. Okay, so I'm going to start with Abu. I'll write up the formula here. So if it's QI, I is quartile 1, so this would be 1 times, now what's N? Marco, what's N? N is our sample size, so yep, N is 20. So that's 20 plus 1, and then this whole thing divided by 4. And what do you get for that, Abu? Yep. Is it 5.5 or is it 5.25? 5.25. So just double check your work. This is 5.25. And that's the position, right? So remember I said that the method that we're doing here is sort of manual. I know you're using your calculator, but manual, meaning we can't get the exact 5.25 position. So instead, we're actually going to round it down to the 5th position. And you're going to count. Now we have our data in increasing order, count the 5th position. And that, if you count to the 5th position, that value, Dong Yang, you're right, is 73. Okay, so if you go up to your chat box, you can see the values that Arzu rearranged. The 5th position would be 73. Okay, Bipin, do you have Q2? So Q2 is I is 2 times N is 20 plus 1, this whole thing divided by 4. And what do you have for Q2, Bipin? So the position is 10.5. Yep, that's right. Which means I need to take the average of two values. So Diana, how did you get 79? What's the average of the two values? Yep. So you 79 plus 79 divided by 2 is equal to 79. Right. Any questions for me? So right now we have 73 as quartile 1, 79 as quartile 3. And then Labna, you're doing quartile 3. So let's pick another color here. So that's 3 times 20 plus 1, the whole thing divided by 4. And Labna, you don't have an answer for us? Okay, so that position is 15.75. Yep, thank you. Which means round it up to the 16th position, and that value is 80. Correct. So again, when you're doing your homework or the exam, when you've calculated quartile 1, 2, or 3, don't stop at the position because that's not the final answer. Make sure you round it up or round it down. Now, get comfortable using Excel with this too, and I showed you how to do that in the previous slide, so know how to get the quartiles using Excel. Interquartile range. I would like to have N. And can you calculate the interquartile range for us, which is, let me change this, Q3 minus Q1. So we found Q3 is 80 minus Q1 is 73. So what's that value for? And do you have that answer? Yep, you have it. 7. Okay.
7, Professor.
Yep, got it. I just saw that. Okay, so then the highest fence and the lowest fence. So now this is a little different with the formula. So let's have Conrad. You can do the highest fence, and we have Yazan. You can have lowest fence. Okay, so let's rewrite this. We have the highest fence as Q3, which is 79, sorry, 80. Q3 is 80 plus 1.5 times interquartile range of 7. Okay, it's the formula that's showing up on the slide here. And then Yazan, you're doing the lowest fence, which is Q1, so that's 73 minus 1.5 times interquartile range of 7. So what do you get for that, Conrad?
One second. Hold on.
Okay. So remember to do the 1.5 times 7 first, then add 80.
90.5.
Okay, so we have 90.5. And then Yazan, do you have the value for lowest fence? Okay. So the answer is 62.5. Okay, 62.5. Any questions on how to calculate this? Because you need to know how to construct a 5-number summary. Rad?
Professor, I just wanted to ask, is this considered same as the turkey method?
Yes.
Okay, because when I was doing the homework, I think it
Uh-huh.
breaks it down into different parts, and then you have to find the middle of that part that I think it breaks it up into half, and then from the other half you get
Oh,
the,
okay. Yeah.
yeah, it was
That's
a little
more
confusing.
precise. Okay. Yeah. So let me mention that actually. That's another way of doing it. So I said to round down out or to round up. So if it was 5.25 position, for example, so that's a good point. Where is this? Okay. So if I said 5.25 position, in the lecture today, I said to round down to the 5th position. But in your homework, if you see view an example, it will say take the 5th position and the 5.5 position and get the average of the two. So that works too. That's fine.
Okay.
Okay. I see a couple points here. Jason, you asked me where does the 1.5 come from? So this is a standard formula. So the 1.5 is a standard formula. Okay, I'm giving that to you. That's the formula we're going to use when you calculate highest and lowest fence. So that doesn't come from anywhere. Okay, Judah, I'll answer your questions in a moment, but now you're going to take these numbers and construct your box plot. So let's move on to the next slide. So here's the box plot, okay? So let's say you pointed out now the x2 value, which is your median. x2 we calculated as 79. We said sorry, not xq. q1, quartile 1 was 73. Was that right? Yeah, 73. No, this is, let's start this over because I'm not writing it correctly. Okay, so Q2 was 79. Q1, quartile 1, was 73. Quartile 3, which is the top over there, was 80. And then we have the two fences. So we have the lower fence was 62.5, I think. Okay. And then the highest fence was, I'm looking at the chat box, I think 90.5. Yeah. Okay. And so now what am I seeing in this box plot? Okay, right away I can see that Q2, my median, is not in the middle of the box. It's not in the middle of the box. If it was in the middle of the box, that means my distribution is symmetric. So this is telling me that the distribution is skewed. And in fact, if I turn my head to the right and I imagine a histogram, I see a long tail to the right. So this box plot is actually right skewed. Also, if it was symmetric, then these lines would be the same length. But in this case, it's not the same length. So that means it's skewed. Okay. So a lot of information I can tell right away with a box plot, right? And remember what quartiles tell us. So if I was looking at quartile 3, which is the value 80, so the number of games that Gretzky played during each of his 20 seasons, and that quartile value is 80, it's telling me that 75% of the observations are less than 80. So good information to know about his seasons. And the last thing is, what about these values at the bottom here? So if I look at my two fences, my lowest fence and my highest fence. Lowest is 62.5, highest is 90.5. And then I go back up the chat box here and look at the data that was reorganized in increasing order. If I see any observations that are beyond these two fences, so either higher than 90.5 or lower than 62.5, then those observations are considered outliers. So if I go up my chat box, you could see here that the observations 45 and 48 are less than the lowest fence of 62.5. So for that reason, these values here are considered your outliers. Yes, those are low outliers. Red, did you have a question?
No, that was from before, sorry.
Oh, okay. Okay, any questions about this, about how to set up your box plot? Okay, so you need to know how to do this. So again, this is asking the same thing that we just talked about. Unusual features means the outliers. So we just identified our outliers. And this slide is really giving you the solution. So I can skip this. Okay, so what can we do with the box plot? Well, let's go back to histogram first before I talk about box plot. So I said that when a histogram is good when you're comparing two sets of data. For example, you're looking here at data using the daily closing prices in 2002, and data on the right is showing daily closing prices in 2003. The only thing I can tell is that, well, it could be kind of skewed for the daily closing prices on the right, but it could be kind of symmetric with the data from 2002 on the left. I can definitely say that the data from 2002 is more spread out, more variable, meaning the standard deviation is more, which means that it's further away from the center. Each observation has a long distance from the center, which means that that expected value, that mean, deviates a lot from each observation. The daily closing prices for 2003 are not as variable. So this is information I can tell with two sets of data. With a box plot, and when I'm looking at bunches of data or groups of data or several groups, I can get a lot more information. So this example that you're looking at is a typical example that you could get again in the homework or the exam. And let me tell you what I see when I look at this graph with all the box plots. Well, looking at the daily closing prices from 2002 to 2009, it tells me that the prices seem to be fairly stable from 2002 to 2007. Fairly stable from 2002 to 2007 because there doesn't seem to be much difference in the box plots. Something drastically happened in 2008. So the daily closing prices dropped significantly. Okay, financial crisis, right? In 2009, it was a fraction of what it was before. So this is information I'm getting by looking at the box plots. Now, what about between 2002 to 2007? Okay, well, it tells me that the typical closing price, daily closing price, seemed to be at $60 or above. Okay, from 2002 to 2007, the typical daily prices seem to be at $60 or above. How do I know that? Because I'm looking at their medians. That's the typical value, the bar in the center of the box for all the years from 2002 to 2007. And it seems like it's at $60. Okay, this is not a good line. But it seems like it's at 60 or above. So that's where I'm getting that information. Okay, let's look at this next slide together. So here's an example of wine prices. The box plots displayed, so this is a bit messed up, this sentence, I need to fix this, but the box plots display case prices in dollars of wines produced by vineyards along 3 of the Finger Lakes in upstate New York. Okay, so you're looking at wine at case prices given in dollars of wines produced by vineyards by the Finger Lakes in upstate New York, Cayuga Lake, Keokuk, and Seneca Lake. Okay, first question. Which lake region produces the most expensive wine? And I'm going to put a poll here, so you have to answer the questions in the poll. Your answer choices are Cayuga, Keokuk, and Seneca. Okay, so again, the question is asking you which lake region produces the most expensive wine? Okay, 10 seconds. Okay, so most of you said Keokuk, and let's see. Does anyone want to explain why you chose a certain answer choice? Judah?
So it's asked specifically for the most expensive wine. So we want to look at the higher fences or high outliers, and Seneca has the highest fence. So it sells the the most expensive wine.
Karina agrees with you, and I agree too. So we're looking at the highest fence for the most expensive wine. Okay, so we don't look at anything else. We look at the highest fence. Next question, which lake produces the cheapest wine? I'm going to put up the poll again. So again, you're not going to get points taken off if you get the answer incorrect, but make sure you really understand how to get the right answer. I'm posting now the poll, which lake region produces the cheapest wine? Okay, 10 seconds. Okay, let's see. So I think you all got it. Yes, Istiak, you're right. Seneca is the answer again because it produces the cheapest wine and it has the lowest fence. Yes, agreed. So now the third question. Putting up your answer choices here. Kiyuka and Seneca. Okay, question is, in which region are wines generally more expensive? Generally more expensive. Okay, 10 seconds. Okay, so I think you all got it. Kyuka is the right answer. So generally, that word generally means typically. So the typical value is our median. So generally more expensive. I don't know why this graph is not showing the rest of this box plot. There's something wrong with it. But clearly there is an outlier here, but I don't know what happened to the whisker portion of that. Okay, any questions for me? Okay, so moving on. The next thing you need to know is how to actually create a plot. And you know how to do that because that's part of your Excel assignment. So I know you all know how to do this manually. If I give you a piece of paper and told you to plot X and Y, you know how to do the coordinates. What you're looking at is something specifically called a time series plot. So you're looking at the same AIG daily closing prices just for 2007 of the AIG closing prices. So it's the first of every month starting from January. And it's so why do we even bother with the time series plot? Why aren't we satisfied with just the histogram and the box plot? Well, the reason we look at a time series plot is because now we want to see some kind of pattern, some kind of trend, which we can't see with a histogram or a box plot. So that's why we look at a time series plot. And if you're using Excel, this is how you would do it, right? You would select the two columns, closing price and date, and then create a line chart. Okay, so if you're given two sets of data, one is closing prices, one is dates on a spreadsheet, and you're asked to create a time series plot, you're basically creating a line chart. Now, if I connect the dots to this time series plot, I get something like this, which is giving me a little bit more shape and meaning, but not really. If I smoothen this out into some kind of a curve where I trace a line, now I can easily get some trend and pattern. I can almost predict what the next price would be for the next month or the next year. So this shows me long-term trend. So that's the reason why we have a time series plot for long-term trend. And that's the last slide for chapter 3. And I'm going to move on immediately into chapter 4. Does anyone have any questions for me? Any questions about the Excel assignment or the exam next week on Tuesday?
Yeah, Professor, the exam is just going to be up to chapter 3, correct?
Nope. The
Chapter 4
exam,
also?
yeah, so it's going to be chapter 1, 2, 8, and 4. So today I will do a little of chapter 4 and I will finish chapter 4 on Thursday. So it is including chapter 4. So follow the syllabus. It's on the syllabus.
Okay.
And questions for me?
I have a quick question. So one of my group members wanted to know that we're having trouble with our frequency distribution table since we're doing income and housing costs. Do we do both of them or income and
No.
or housing costs? Okay.
No, so when you open your data set from the textbook, I know there are many columns with many sets of data. You're only going to pick one column,
Okay.
but make sure that column has data that is numerical, meaning
Okay.
it has quantitative values, right? You don't want countries or states. Yeah, so only use one set of data.
Okay. Thank you.
Okay. Sophia, your question is, what do you mean manually? When I use the word manually to draw a graph, I mean grabbing a piece of paper and drawing it by hand with your X and Y coordinates. When I refer to manual calculations, I'm talking about using a calculator. When I say use technology or software, I mean Excel. Okay. I will not do a review, Jennifer. On your chat box, it says, will I be doing a review? I don't have time because on Thursday I finish up chapter 4 and then your exam is on Tuesday. But I will post a review sheet on MyLab under document sharing. But again, the review sheet might not really help you. What would really help you is your study plan, because it's everything that I'm covering in these PowerPoint slides, right? So go over your homework. That's the best thing to do. A review sheet just gives you a list of topics, which is basically everything in the PowerPoint slides. And then let me go up and see if I missed anything else. Yeah, so Istiak, your question was answered. Judah answered it. It's the time of the class. That's the exam time from 12:15 to 1:30. So Abraham, you have a question. How long does part E have to be for the Excel assignment? So that portion of the assignment says to tell me what do the statistics tell you from the histogram? I think that was what the question is. So tell me, is it symmetric? Is it skewed? What's the frequency for the highest bar? What is that telling you? What's the lowest bar? Does there seem to be a wide range? Is it so spread out? So a lot of information you can get by looking at a histogram. So a few sentences, okay? The questions on the exam will be very similar to the homework questions. So Alicia, you asked me, for the Excel assignment, the histogram is based on the cumulative percentages or the raw data. The histogram is based on class and frequency, but the ogive is based on class and cumulative percentage frequency. Okay, if you need more clarification with that, you can send me an email. And I didn't forget, at the end, I'm going to fix the Blackboard submission. I know that there was an issue with that, so I'm going to check on that. Okay, another question here in the chat box. Will exam 1 be based on chapters 1, 2, 3, 4, and 8? Yes. Okay, so now chapter 4 is correlation and linear regression. So this is actually a very important chapter because it's the basis of all statistics, correlation and linear regression. So in the last few chapters, we talked about how to organize qualitative data and display it as a bar chart or a pie chart. Then we talked about how to organize quantitative data, either the frequency distribution table or the cumulative frequency distribution table, and display it as a histogram or a polygon or an ogive. Okay, now we're going to look at two variables and see whether there's some relationship between the two variables. Is there some association between the two variables? Okay, so let's move on to the next slide. So what you're looking at is a scatter plot, very basic scatter plot, right? With your X and Y values. So here, a scatter plot plots one quantitative variable against another. So I'm going to stop right there because that's important. You cannot create a scatter plot if you do not have quantitative variables. So they both have to be quantitative variables. Remember, they could be discrete or continuous, right? So this is an effective display to look for trends, patterns, relationships between the two quantitative variables. So there you go. Scatter plot is giving you this information. That's the reason why you're plotting X against Y, to see some relationship. What's the trend? What's the pattern? What's going on between these two variables? So it's an ideal way to picture associations. So if we look at the x-axis, we're looking at the first quarters from 1995 to 2004, the first quarters for each of these years. And the y-axis is telling you it's seasonally adjusted housing starts in thousands. So in other words, the housing prices for the first quarters from 1995 to 2004. So immediately by looking at the scatter plot, how would I answer the question? Have housing prices increased over the years? What do you think the answer to that is? Have housing prices increased over the years? Yes, of course. Yeah. So immediately you can see that you don't have to go searching through the data. You plot it and you can see there's some trend here. There's a pattern here. Okay, so moving on. These are the things we're going to look at when we see a scatter plot. The four most important elements or features are direction, form, strength, and outliers. So let's start with direction of the scatter plot. So it's the direction of association. A pattern that runs from upper left to lower right is said to be negative. So in this direction, this would be negative. A pattern running from the lower left to the upper right is called positive. So this would be considered positive. Sometimes it's very easy to tell if your scatter plot is positive or negative. Sometimes it's not. And if it's not, then we have to use more advanced techniques. We might have to use a software program. We might have to use some different formula. We might have to go back to the drawing board and pick a sample that is not as biased. So it could be anything. Okay, let's move on to the second thing, which is form. So when we look at the scatter plot, we're interested in form. If there's a straight line relationship, it will appear as a cloud or swarm of points stretched out in a generally consistent straight form. This is called a linear form. So let me put some dots here to show you what I'm talking about. So if I had dots, and you can't really see it, but I'm trying to show a bunch of dots that are going basically in a straight line. So it's not curved, it's giving me a straight line. That's considered linear. There's no curve. But sometimes if there's a slight curve, maybe it's going slightly this way or maybe up and down, that's not linear. So we're trying to look for a scatter plot that is linear because we get better information when the relationship is linear. Okay. Any questions for me? Next thing is the strength. Did it go? Okay, so the third feature to look for in a scatter plot is the strength of the relationship. So if the points appear tightly clustered in a single stream, then we say they have a strong relationship. X and Y have a strong relationship because all the points seem to be tightly clustered. But if your points are spread out and so variable that you can't really figure out what pattern it is, then we say that it has a weak relationship. So when we talk about strength, we're looking at scatter. And then finally, we look at outliers. So again, outliers are something that are completely different. Always look for the unexpected. An outlier is an unusual observation. It stands away from the overall pattern of the scatter plot. So something that is completely atypical of your data set. Okay, very unusual. So why do we talk about outliers? Because that's an indication that something's not right. Is there an error, or ask the question, why is it so different? Maybe the sampling method was not correct. So things to think about when you see any outliers. Questions? Okay, so we're going to look at this new example. And I'll read and then explain. The Texas Transportation Institute issues an annual report on traffic congestion and its cost to society and business. Describe the scatterplot of congestion cost against freeway speed. Okay, so What is this telling us? There's this institute called the Texas Transportation Institute, and it issues an annual report on the traffic congestion and what it costs to society and what it costs to businesses. Okay, so you're looking, they did the work for us. They created the scatter plot. They collected the data. The x-axis is peak period freeway speed given in miles per hour. Okay, peak period freeway speed. The y-axis is cost per person, dollars per person per year. Now, before we talk about the scatter plot, I'm going to ask you, what has cost per person got to do with congestion cost? So freeway speed, we understand. That's the x-axis. Peak times freeway speed, we get it. That's easy to get. What is cost per person, and what has that got to do with congestion cost? What do you think? How do you think congestion cost is collected? So Mark, you say loss of productivity. Okay. Anyone else? So congestion cost is done using many factors. So these are common feasibility studies that are conducted, and there are many factors that go into congestion cost. Loss of productivity is one thing. There are many different costs associated with this. Opportunity cost, the cost of gas, so again, many things, but they have a system of calculating this and putting a price to it or a cost to it, and that's a cost per person. So that's the congestion cost. So you're not asked to do that. This is just a side question, but it's interesting to know how they collect this information. Okay, so I'm going to start with direction, and I would like Yogita, can you tell me about the direction? So either positive or negative, right? When you're looking at the scatter plot, Yogita. Okay, so let me go with Mihakpreet. Why negative? So negative is right. It's not positive, but can you explain, Mihakpreet, why it's negative? And give it to me in terms of cost per person and peak period freeway speed. Okay, can someone else explain to me in terms of the variables that they've given?
What was your question again?
So my question is, and I think Abraham just answered it, my question is, why is it negative? And give it to me in terms of the variables given. So Abraham is saying, as the cost goes down, the speed goes up. I'm going to change that in a different way of saying it, right? Because I'm not going to say as the cost goes down, I'm going to say as X, something happens to X, then something happens to Y. So Judah, I'm going to go with what you said. As something happens to X, as people are able to go faster on the freeway, because you can see here the freeway speed is from 45 miles per hour to 60 miles per hour. So as people travel faster on the freeway, then the cost per person decreases. Then Y decreases. So be careful when you're interpreting the answer. I agree it's negative, but when X increases, that's when Y decreases. Questions? So it might seem very simple, but you have to be very careful when you answer the question. Okay, so this direction is negative for this scatter plot. So it makes sense, right? When we have traffic congestion and the cars are not moving fast, okay, they're moving less than the speed limit, around 45 miles per hour, it costs a lot. It's actually congestion. So the cost per person, it's costly to society and business. So that makes sense. Okay, let's move on to the next thing that we look at for a scatter plot, which is form. And I would like Morshed, can you give us that answer for form?
Couldn't get that,
Yeah.
man. Which
Okay,
one? Like,
sure. I'll help you. So form is talking about if you see a straight line, or do you see some kind of curve with the points on the scatter plot? So is it a linear straight line, or is it some kind of curve?
it's a curve. It's going down from the top to bottom.
So if you had to draw an imaginary line, so I'm going to draw it for you. This is kind of the line that we would get, right? Something like this. If I had to draw a line between my points. So this is telling me it's pretty much linear. Okay, if
Okay.
this was not, so for that reason, I'm going to choose linear. Let's say the points on the scatter plot was something like this, and then it went like this. Now it's not linear. Now there's some kind of curve. If I had to draw the line, I would get something like this. So that would be incorrect. It's not linear. But what they've given us is linear. So the answer for form here is linear. Everyone agrees? Do you not see that? Okay. Na Young, can you do the next one for us? The next thing we look at is strength in a scatter plot. So strength refers to how scattered the points are on your scatter plot. Are they spread apart, or are they tightly clustered together? If they're tightly clustered together, there's a strong relationship between X and Y. If they're scattered far away from each other, then it's a weak relationship. So Na Young, what do you think?
I don't think they're very scattered a lot. I don't think they're kind of tied to each other.
Okay,
Kind
perfect.
of close
Yep.
and why relationship.
Sure. So I agree. I think that too. In the beginning, it seems scattered, and then later on, it's kind of tightly clustered. So it's hard to tell whether it's one way or the other. So maybe, moderately clustered. Maybe it seems like a moderate relationship. So there's not much of a strong relationship between peak period freeway speed and congestion cost. Doesn't seem to be a strong relationship between the two. So that's what this scatter plot is telling us. Okay, and then Mirza, can you look for outliers? So just before you answer that question, let me answer the question in the chat box. It's moderate, it's not weak, Priscilla. So to answer your question, it's moderate. Mirza, do you see any outliers? That's the last feature you would look at in a scatter plot. So something that is completely different from the rest of your data set. Anyone else want to answer?
I don't really see that there are any outliers. There are two that are slightly below the curve, but for the most part, they follow the trend.
Correct. So Shamaya, you're also right. These are not outliers. Not outliers. Mirza, yes. So you say they're closer at the end. There are no outliers. So the answer is no outliers for the scatter plot. If there were outliers, it might have been a value over here, something that is completely different from your data set. So it doesn't make sense, right, to have this coordinate at 60 miles per hour. How can the cost per person be so high? Something's not right. Completely different from my data set. So that would have been an example of an outlier. Questions for me? Okay, so we're going to do a different example. Okay, so you're looking at two columns. The first column says year, second column says mean age. Again, this is a typical example you could get on the homework or the exam. So you're told to make a scatter plot and summarize what it says. Okay, first of all, what is this data? I'll give you some background. Cycle accidents have become a serious concern for insurance companies. So what they did is they collected data from the year 2000 up until 2015, and they looked at the mean age of cyclists who were killed each year. The mean age. Why do they want that information? Maybe because they want to figure out certain insurance policies. I don't know. So they've collected the data. And let's say you get a question like this on the test. First thing you should be able to do is be able to create a scatter plot on Excel. So you would highlight year and highlight mean age, include the headings, do not include totals, and you create a line chart. That's all it is. So you're already doing this with your Excel assignment. Okay, so just get into the habit of doing it. Now, the next slide actually gives you the answer. So again, when I say you can easily do this manually, meaning you take a piece of paper, you can draw your X and Y, put your coordinates, and you've drawn it. But since we're doing this all online, you're expected to do it using Excel. Okay, so again, let's do this fairly quickly. I think you understand how to do this. So Anna, can you tell us about the direction? So direction choices are positive or negative. Looking at the scatter plot. Okay, so it is positive. Let's have Detrick, can you tell us in terms of the variables what positive means? So Detrick, you're telling us that information, right? I agree it's positive, but give it to me in terms of the variable. Mark, do you want to reword that? So Diana, that's correct. As the year increases, the mean age increases as well. So Mark, you say as age goes up, year goes up. So Mark, that's wrong. Because if you look at your first response in the chat box, that's correct. You have to start off with the year. So Diana, you're right. Every year, it seems like the mean age increases. Okay, so every year, the mean age increases. So that's important information for the insurance companies. It's interesting to them that every year the mean age increases. Okay, next thing is form. So can I have Aliza, can you tell us about form? So again, form is either a linear line or there's some kind of a curve happening with the observations. It's pretty linear. Correct. I agree. If I had to draw a line through this, it's going to be quite a straight line. Yep. So it's linear. The next thing is the strength. So Dong Yang, what do you think about the strength? Are they tightly clustered together or are they fairly spread out? Dong Yang? Yes, tight is correct. So that means this is a very, very strong relationship. And the relationship between X and Y is so significant, it's quite strong, that this is a great model for them to use. It's really saying that there's some relationship with every year of progression, the mean age increases. It has something to do with each other significantly. So interesting information. The last slide today is a bunch of definitions which you need to know because they are important. So it's actually just this, X and Y. Now, when you're doing your homework, you might not always get questions that ask you about X and Y. You might get something that asks you about the predictor variable or the response variable. So the best way to remember this is X explains Y. X predicts Y. X is independent of anything. Now Y responds to X. Y depends on X. So you need to remember the terminology. So if I go back, let me show you what I'm talking about. If I go back to this slide and I ask you what's the predictor variable, how would you answer? What's the predictor variable? Yes, Diana, you said it's the year, and that the year is predicting the mean age. What about if I go to this slide and I asked you about the response variable? What's my response variable? So yes, cost per person or congestion cost would be the correct answer. Yes. So that's my response variable. Yeah, so that's it for today. I'm going to stay on a little bit longer. I'll stop the recording and then you can ask me questions about Excel or anything else. Okay, so thank you, everyone. Okay, I'm stopping the recording.